We're going to take a look now at Chapter 9, Section 1, which deals with composite functions and inverse functions. But we'll start with composite functions. Now, in our textbook, it starts off talking about, in the real world, we often think of some quantity depends on a variable that in turn depends on another variable. For instance, a firm's profit may depend on the number of items the firm produces, which may in turn depend on the number of employees it hires. Now, when you have this type of relationship, one function is depending on another function. That's the definition of a composite function. So what we're going to do here is take a look at the example they give us in our textbook. Now they say in the United States, the shoe size, let's say for a female, and the shoe size in the UK has a certain relationship to it. So for instance, here we have that whatever the shoe size in the States is, which is, let's say, X, that in England, the relationship is going to be that shoe size minus 2. So if we input here, let's see if I write that correctly, and I want to put in there a 4, that's the female shoe size in the USA, that in England, or the UK, that shoe size will be 4 minus 2, or 2. So that's the thing about the comparison of shoe sizes in the United States to a shoe size in the UK. Now, how about the relationship of the shoe size in the UK and in Italy? Well, if we're saying the shoe size in the UK has this machine, so to speak, and we'll go into that in a little while here, what would be the relationship in Italy? Well, for there we can use, say, another letter. And it's twice the shoe size in the States minus, or I should say plus, 28. So we're getting a couple of different relationships then. So now I'm going to write something here. So we get this composite function in which we're saying the function of g of x, where x up here is this, that we're putting there. We then go to our Italy function, where the x, this x, is this, And this x right here will be this. So a step back and looking at the whole picture again is, if in the States the shoe size is X, and we're saying that we're talking about a specific shoe size of 4, that in England it's going to be, the relationship in England is the American shoe size, which we said was X, which is a 4. 4 minus 2 now, that's the function. We end up with a 2. So the shoe size in the States would be 4. The shoe size in England for that same shoe would be 2. Now, how about the shoe size in England and in Italy? Well, we said the relationship in Italy would be twice what X is plus 28. Now, what did we say X was? Well, our X here for the G function is X minus 2. Okay, so that's where it gets a little tricky. So now we're going to put our X minus 2 where this X is. So when we multiply this through, this becomes 2x minus 4 plus 28, which will then become 2x plus 24. Now, if we go back and say, what was our x? Well, our x was 4. 2 times 4 plus 24 is equal to 32. So the shoe size for this same shoe in the United States, which was 4, in England it was 2, in Italy is going to be 32. And this was the example of a composite function, where you started with something, you had it related to something else, which is related to something else. So what you will need to reference perhaps from time to time is the formal definition that I have in blue here of the composition of functions. The composite function of f, and then this is like a little circle. Composite function of f circle g is one way to read it, or the composition f of g, or fng, and another way to read it is f composed with g, and then that final way we said f circle g. So this little circle in there indicates composition or composed. And then the way to write that is this. So this is sort of one way to write it, but it's equal to this. All right, and we're going to see an example of this on the next page as well. So in example 1, we have given f of x equals 3x and g of x equals 1 plus x squared. So these are two functions, and they're asking us then in the first part, find the composition or f circle g where x is 5. Now when we do it, we always take the second letter, which is g, first. So first we do the g, which we're saying is 5. So we now have, remember our function of g is this, so it's going to be 1 plus x squared. And we're saying that x is going to be 5. And that's going to give us a 26. Now that we know our new x value, we're going to do the f of x, and its x is going to be 26. So we do 3 times, remember this is 3x, and we say our x now, as part of the composite function, is 26, and that will give us a 78. Now, for this one, notice it's reversed. Instead of the f being first, it's now g first, then the f. So again, we first do f, which we're going to say is 5. That would be our x value. So we go to our function, which is 3x. We now put in the 5. And we get 15. We now apply the 15 into our g function, which is 1 plus x squared, and that will be 1, and our x value is 15. Well, let's put the value there. So 15 squared is 225, plus 1 is 226. Now we know that these two do not equal each other, because when we do the first composition, we get a 78. When we do this composition, it's 226. Okay, I'm going to leave that up because we're asked now to do another example. Now we're using the same given, but now instead of using the value 5 here, we're just going to use the value x. So the f circle g, or f composite g, and g circle f, or g composite f. And again, we'll use the same thing. First, so as we start this composite, first we do g of x, which g of x is this. So our x is 1 plus x squared. 1 plus x squared. Then we now know what our x value is. We then go to our f function, and our f function is 3x. Well, this is our x. 3x, this is our x. So we substitute there and then just distribute, and we get this. So when we are finding the composite of this, given this, in this B first part, we get this. All right, let's go on to this one. So here we want to look at what F is. First, then we get our f of x up here is 3x, which is our 3x. Then we apply the g function, which is 1 plus x squared. Well, what did we say our x was here? Well, this was our x. So our x goes right where the x is. So we will square that. So we then get, let me write it here, 1 plus, now 3 squared is 9, and then x squared. Now, an interesting thing happens here, that if you recall initially we had a 5 and a 5. If we say x is 5 here, watch what happens. 3 plus 3 times, we said x was 5. What is 5 squared? 25. 25 times 3 is 75. Plus 3 is 78. Wow. Okay, so that means that in a sense checks out. Now how about this one? Again, we said x is 5. So we're going to have here 1 plus 9 times 5 squared. Well, what is 5 squared? 25. 25 times 9 is 225 plus 1, 226. So these check out. Okay, we'll be going on to example 2 and others as we go on.